We're going to continue 6.12, and we're going to look through example 3 in this video. So first thing you want to look at is that this little note here that says, perhaps you're wondering what happens when the denominator of a rational expression contains repeated linear factors, such as this one where we know we've got two factors in the denominator that are x minus 1. That's what the squared means. So in this case, the decomposition looks like the following. If the degree of p of x is less than n, then we can write. So when we have an n factor, so like a squared, I have to include the factor before it, so one that's just a single factor, and then I also have to include the squared factor. If I had a cubed, I'd have to go one more. And then we have to determine constants for a and for b. So let's take a look at one that's a repeated linear factor. Ones like these aren't covered on the actual AP test. However, you typically do see these in a Calc 2 class in college. So sometimes it's good for us to see things to stretch our brains a little bit and see things that are going to be, that we possibly would have seen in Calc 2, which is what this class here covers. In college, you would get credit for Calc 2. So, and that way, when you go to Calc 3, you know how to do this, hopefully, or at least have seen it. So I'm going to split this. I'm going to do my skeleton of my integration up here. And the calculus is like literally a line. So we're going to need the rest of the space to do the algebra. So I'm going to go ahead and factor this piece here. So I've got x, and I pull that out, and I've got x squared plus 2x plus 1. And then when I factor that piece with my magic x, I get 1 and 1. So I get x times x plus 1 times x plus 1. So in this case, I'm going to have 3 factors. But the way that I set this up is a little bit different than what we were seeing before. So we've got an x underneath one of them. We know we're going to have an x plus 1. But then according to that rule we just wrote, instead of putting a second x plus 1, we're going to go x plus 1 squared, because that's the rule when we have a repeated linear factor, is we have to write it that way. So I'm going to do my ABC. I know that I'm going to be equal to the 5x squared plus 20x plus 6. And we are going to multiply by what's missing, right? Because technically what we're doing is canceling fractions. So I am going to multiply by this. What's missing in this one is really the x plus 1 squared, right? Because I'm really looking at what's missing here, because I have to multiply by the common denominator. So I would really have multiply this by x squared plus 2x plus 1, because I know that's what these are when we multiply them together. I'm going to distribute that a. So we get ax squared plus 2ax plus a. Then I'm going to multiply this one by x times x plus 1, because that's what would be missing from here. So I'm going to distribute this in. So I get bx squared plus bx. And then finally, I'm going to multiply by what's missing here, which is just an x, so plus cx. Now we're going to go through and we're going to do an x squared equation, which looks like I've got 5 equals a plus b. And then I'm going to do a x equation, which looks like I've got 20 equals 2a plus b. And then I'm going to do whatever I have left here. So I've got the 6, the a. Oh, I missed something on my x equation, didn't I? I missed the c, didn't I? So we're going to put that in there, plus c. 6 and a are all that I have left in the other equation, so I'm just going to write 6 equals a. Okay. I'm looking at what I did before, and apparently I messed up somewhere, but that's okay. It's going to work out. So notice it solved itself, right? So I could now take that a and I could plug it in here, and I could plug it in here. So I'm going to start by plugging it in here. So 5 equals 6 plus b. And I'm going to subtract that over, so -1 equals b. Well, now that I have a and b, I can plug into here and get c. So 20 equals 2 times 6 minus 1 plus c. So 20 equals 12 minus 1 plus c. 20 equals 11 plus c. So c is equal to 9, right, when I subtract. So when I put this all together, I missed getting the x plus 1, and the x plus 1 squared. I am going to see that I have a is 6, b is -1, and c ends up being 9. And then I'm going to start integrating. So when I integrate this one, I know it looks like a 1 over x. So that's 6 natural log absolute value of x. And then minus 1 natural log absolute value of x plus 1. Now, this next one's a little bit trickier. So I'm going to kind of do some work off to the side here. So we've got 9 on the outside of 1 over x plus 1 squared. Well, this isn't a natural log because I've got a squared right there. So I actually need to do, I'm going to bring this upstairs. So it's like saying 9 x plus 1 to the -2 dx. That, I guess I could use a u substitution, but if you think about your u on that, it's just dx. So I don't really need the u. I'm going to skip the u part. So when I integrate, I'm going to follow my normal power rule integration. So I've got just the 9 hanging out. And then I'm going to add 1 to it. So when I add 1 to it, I'd get x plus 1 to the -1 divided by -1, but then I would put that back downstairs, right? So I would have a -9 here, and then it's over x plus 1 to the first, right? And then everything plus c.